Welcome to T2, day 21 of calculus. Today we are going to solve equations algebraically. So in this first one, it says solve 200x to the negative 2 plus 8x equals 0 and check your answer. So there are lots of paths. I'm going to try to express what I think is the simplest path. The first thing I recommend doing is dividing everything by 8. The smaller you can make numbers, the better. So if you do that, you end up with 25x to the negative 2 plus x is equal to 0. What does x to the negative 2 mean? X to the negative 2 means 1 over x squared. So what does that mean? It's 25 over x squared plus x is equal to 0. So let's move this x to the other side right there. So you have 25 over x squared is equal to negative x. I'm going to make it over 1 just so you can see what's coming next. And now I'm going to cross multiply. If I cross multiply it with negative x cubed is equal to 25. So x cubed is equal to negative 25. So to get rid of a cube, you need to take the cube root. So you have x is equal to the cube root of negative 25. And you might say, hey, I can't take a root of a negative number. Well, you can because this is odd. So how would you check this answer? You would check this answer by taking this number right here. You could use your calculator, taking this number and plugging it in for x in both cases in your calculator and seeing if it comes out to be a true statement. And it will come out to be a true statement. You just need to plug the number in and check to make sure it comes out to be 0. So now we have a of x is equal to 1/2 x times 100 minus x squared. State the domain of this function. The domain is the set of all numbers that you're allowed to plug in. What are all the valid possible x values? The two things you're trying to watch out for are dividing by 0 and the square root of a negative number. Well, there's no division here, but you do have a square root. So you need to make sure 100 minus x squared is greater than or equal to 0. So that means 100 has to be greater than or equal to x squared. So what you do is you can write that as x squared has to be less than or equal to 100. So when you square x, that has to be less than or equal to 100. You could take the square root of both sides of this. You just have to be very careful. You can also do this one. I think it's easier to do it by logic. So when you're looking at a number line, what numbers when you square them are less than or equal to 100? Well, what's the biggest number it can be? 10. And what's the smallest number it can be? Negative 10. Negative 10 squared is also 100. So what does that mean? The domain is between these two right here. So you can either write it as a number line. I prefer to write it like this. X such that x is greater than or equal to negative 10 and less than or equal to 10. If x is outside of that green region, then this right here would be less than 0, so therefore you'd be taking the square root of a negative number. Now the real fun begins. Find all maximums and minimums exactly and verify which is which, a max or a min. So we need to take the derivative. So we have our original function. I'll just write it again. Is equal to 1/2 x times, we had the square root of 100 minus x squared. To take the derivative, I'm going to set it up and make it a little easier on us. It's 1/2 x times 100 minus x squared to the 1/2. In order to find maxes and mins, we need to look at the first derivative. So we take the derivative using the product rule, and that's going to be the derivative of the first times the second plus the first, not 1/2 x, the first, if I can get that to erase, there we go, the first times the derivative of the second. What's the derivative of the second going to be? Well, that's going to be 1/2 times 100 minus x squared to the negative 1/2 times negative 2x. So before we do anything else, let's see if we can simplify something here. Can we simplify anything? Well, this 1/2 cancels with that. You still have the negative there. So what does this turn into? Well, we have to be really, really careful. We could, it's about as good as we can get. So if we're looking for mins and maxes, we need to set this thing equal to 0 because we want to know where it's increasing and decreasing. So you might remember that we've taken the derivative and set it equal to 0 many times. So if I take this whole thing, I'm going to write it out again. I'm going to set it equal to 0 because we want to know where it's not equal to 0. So first we found out where it is equal to 0. Let's divide everything by 1/2 so we can get rid of the 1/2 right there. And keep in mind we still have this negative. So let me clean this up a little bit. And this is what you end up with. Remember that negative sign is there. There's an x there, so it turns into x squared. So now I'm going to take this and move it to the other side. So we get x squared times 100 minus x squared to that negative 1/2 is equal to 100 minus x squared to the 1/2. This is helpful. So what does that negative 1/2 power mean? It means that it's x squared over 100 minus x squared to the 1/2. And this, the right-hand side stays the same. It's over 1. So now let's cross multiply. So if we cross multiply this, if we cross multiply that, you end up with 100 minus x squared to the 1/2 times 100 minus x squared to the same thing half equals x squared. But you have a half and a half, and it's the same base, so you add the powers together. So you end up with 100 minus x squared to the 1/2 plus 1/2 is 1 equals x squared. So you end up with 100 minus x squared is equal to x squared. So you end up with 100 is equal to 2x squared. So x squared is equal to 50. So x is equal to plus or minus the square root of 50. Now that we've done that, we need to make a number line here. We have negative the square root of 50, and we have positive the square root of 50. And we need to know where this is the x value, and this is going to be the derivative a prime. And you can use your calculator here to find out where is it positive and where is it negative. And you're looking at the derivative right here. The derivative is this big long one. You can use the simplified form right here. You could use the simplified. So you pick a number. Remember this, you pick a number in between, so you could pick 0. And what you find out is that it's going to be positive right here. It is positive right there. It's positive, right? So it's increasing. The function is increasing. You also know that outside of here, when you test these numbers, these are going to be decreasing. But one thing that's important to remember is that in our first part here, we know that the function only is defined between negative 10 and 10. The square root of 50 is like 7 point a little. So here is negative 10 and here is positive 10 right there. So we want to know what's going on here. It says find all maximum minimums exactly and verify which is which. So what's going on here? The function is decreasing and then increasing and then decreasing. So we have a minimum here, a minimum there, and you have a maximum right there. So write that at a minimum when x is equal to this negative square root of 50, and a max when x is equal to positive square root of 50. And if you wanted the y value, you'd need to plug that into the original equation, which is right there. You could plug it in and get the y value. But those are the exact ones right there. And now you're fully prepared to do number 3 on your own. Very similar to work with to what we just did. Be very, very careful.